Welcome back, friends. Let's look into the couple of problems on the springs. So in this question, 5 people with the combined mass of 275 kg into a car. The car's 4 springs are compressed to a distance of 5 centimeter. Determine the spring constant of the springs. Assume the mass is distributed evenly to each spring. So there are 5 people having the mass of 275 kgs in combined. So let's say this is a car, and then rather than showing the tires, I'll show the 4 springs, as we are talking about the spring force right now. So these are the 4 springs, and then car's 4 spring each compressed to a distance of 5 centimeters. So this tells me that the weight is equally distributed, and then Ryan is also written here. Assume the mass is evenly distributed over the 4 springs. So what's gonna happen is that whatever the springs, because they all are made up of same material, first of all. So if they are made up of the same material, whatever the spring stiffness of this one is, same spring stiffness will be for this one, same for this one, and same for this spring. So if I can find the spring stiffness for one of the springs, I'll be able to find the spring stiffness for the rest of the springs also. That will be the same. Now, if the mass is given to me, mass is 275 kg is given to me of 5 people, and how much force due to gravity which is acting in the downward direction, I will say Fg value will be equal to mg, and then mg value will be equal to 275 times 9.81, which comes out to be 2697.75. This is the force due to gravity, total force due to gravity which is acting in the downward direction. So Fg on one spring will be equal to, on one spring will be equal to this value, 2697.75 divided by 4. So because there are 4 springs, so this value comes out to be Fg is 674.43 newtons. So this spring force, I wanted to find the spring constant. So where it is, determine the spring constant. Whenever we are trying to find the spring constant, or for that matter any other value, either the displacement or the mass, what I like to do is I like to solve the questions by not thinking about the directions. We can later on figure out the direction. We will take the formula without considering any direction. So the formula will become kx equal to mg, which is equal to the mg, which is equal to fg, which we've already figured out here, which is equal to 674.43, which is equal to kx. So k value will be 0, the x value 0.05, equal to 674.43. now divided by 0.05, because this is given to us, displacement given to us is in centimeters, so I have to convert it into meters. 0.05, so this value 674.43 divided by 0.05, which comes out to be, k value is 13488.6 Newton per meter. That's the unit for the spring constant. So that's how we will solve a question like this. So let's look into another problem now. So this is a little more trickier compared to the previous one. So a 100-gram mass hangs motionless from the spring attached to a ceiling. The spring constant k is given to us, so k value is given to me 1.014 Newton per meter, and the mass is 100 grams, which will be equal to 0.1 kgs, because 1 kg equal to 1000 grams. So from there you can find this value comes out to be 0.1 kg, and the instructor pulls the mass through a displacement of 40 centimeter. So let's try and draw the diagram for this one. So instructor, this is the spring mass system given to me. If this is under the equilibrium position, it's here. When the instructor pulls it downwards, so he's pulling it downwards to a displacement of 40 centimeters, which is equal to 0.4 meters also, and then he releases it. And determine the acceleration when the mass is at the displacement of 15 centimeter up. So 15 centimeter up means, so when it's somewhere here from the equilibrium position, 15 centimeter up. At that time I wanted to find the acceleration. Now let's solve this question. So we can say that kx equal to, again as I said earlier, I like to solve these questions without considering any direction. Then later on we can find the direction of acceleration by looking into this diagram again. So kx equal to ma value which I wanted to find out, mass value is 100 grams or 0.1 kgs. K value is equal to 1.014 times x value is, the displacement is 15 centimeter, because we wanted to find the acceleration at a displacement of 15 centimeters. So it's 0.15, so 1.014 times 0.15 divided by 0.1. So let me do these calculations. So this value comes out to be 1.521 meter per second square. That's the acceleration value. Now I wanted to find the direction of the acceleration. So this is moving in the upward direction. I wanted to find the acceleration. So think about this. When this is moving in the upward direction, the spring mass system here, it is compressing this spring. So it is compressing this spring, means restoring force which is getting developed is in which direction? The restoring force is in the opposite direction. When the restoring force is in the opposite direction, acceleration will also be opposite to the displacement, because it's slowing down. As the spring is getting compressed, its motion is slowing down. So if the motion is slowing down, so it means the acceleration is in the opposite direction. It's same like when you're driving a car, when you apply the brakes, although you are moving in the forward direction, but your acceleration is in the opposite direction. So imagine this, you're driving in this direction, but you're slowing down, so acceleration will be downwards. So the acceleration value will come out to be negative 1.521 meter per second square. So we figured out the first part. Now find the maximum speed of the mass. So I wanted to find the speed of this mass. So we've already figured out the formula. The speed formula is equal to a times, this word is crucial, find the maximum speed. If I wanted to find the maximum speed, so I have to consider the maximum displacement also. V equal to a square root of k upon m. I'm not sure about the formula, so I'm gonna I think, yeah, this is the formula. So let's look into the answer for this one. So this value will be equal to let's see, what is the value? A value is 0.4, and let me I'm not 100% sure about this formula. Let me drive this formula. So this value is equal to half kx square equal to half mv square. So if I look into this formula, velocity value will come out to be k upon m. X will be outside. Yeah, so this is a correct formula. So now let's come back to the question. K value is equal to K value is given to me, which is 1.014, and mass value given to me is 0.1. So how I'm going to solve this? First of all, I'm going to solve whatever is inside the square root and then multiplied by 0.4. So 1.014 divided by 0.1, and then I will square root this value and multiplied by 0.4. That's going to give me the answer. So velocity value will be, maximum velocity is 1.27 meter per second. So that's the velocity value. So hopefully you're able to understand these couple of questions, and that helped you to understand the concept of springs. So I'll see you with another video, and bye now.